Hey everybody, Josh here with May Handmade. Today I'm going to use my XTOOL D1 10 watt diode laser. I'm going to use my RA2 Rotary tool, and I'm going to show you how I set it up with just a tumbler. I don't have one that has a mug handle currently. I just did some for a customer, but I don't have one to show you, but I will mock up the way that I set those up to. Um, I'm going to go through how I did it in Laserbox, and now in Creative Space, it's much simpler, and I will go through the setup in there also. And I will show you some of the some of the problems I used to have with Laserbox, and I see that some people still are having the same problems with Lightburn. So this may help some people with Lightburn, even though I'm not using Lightburn, just to understand what's happening when it goes to the RA2 attachment. Um, so let's dive right in. Okay, so first off, I've got my laser, I've got the shroud removed. I remove the shroud when I use the RA2 because when I attach to a cup, a lot of times I attach on the outside diameter of the cup, and that causes these to interfere with the shroud sometimes. So to avoid that and avoid that the shroud may hit the handle of the mug or cup, I just take the shroud off, and it avoids any problem with a collision with the tumbler on here with the mug handle. You can imagine the mug handle hanging off and it's low. It's going to be very close here. So what I do is I use 2x4s and I space up the RA2. So now that I have that spaced up with 2x4s, I'm going to put a couple of little weights here in the back just to avoid any tipping. I'm going to go ahead and release the chuck here so that I can put this cup on here. This is just one that had some mistakes on it. I'm just going to use it for demonstration. So the bigger mugs, I like to go on the inside just to avoid any interference. And just remember that when you're on the inside, you're going to be turning the chuck the opposite direction to expand it, to tighten it. So with this fully inserted, where it's up against the chuck, I've got it tight. See, this is not level. So I put my level on there. It's definitely not level. So then I'm going to come in with my leveling tool that was provided from XTOOL, and I'm going to level it here. So this is going to lift, it's going to lift the rotary tool a little bit, which is perfectly fine. Okay, so we've got a level there. And if you're concerned of any gap here, it usually does not move on me, but you can take the little pieces of wood and just shim until the gap is taken up so that there's not a gap. So that got kind of snug here in the back. I'm not going to worry about it. Still got level. When you set this up, my recommendation is go ahead and level it here. Put your kickstand down. Set your focal length. Kickstand up. So whenever you're setting up, you can see the beam here, the gantry. You can look down on it and you can look at the level or where the cup is to make sure it's straight. Or you can set yourself up something on your grid or the way that it's held up to make sure everything is square. Sometimes I will just use the laser crosshair and I will run it from a known straight place on the cup from the top to the bottom and just make sure that it stays true and straight. So if I knew where center was here and where center was there, just make sure that the cup is straight and it's not turned in there. So the rotary tool could be turned, like right now it is. It's turned a little bit. You can also use these pieces here. They're straight with the rotary. which is also straight with the cup because I maxed it out there. So pick an edge on that, put your crosshairs on it, move to the other side, and you can see if it moves in or out. So right now it's still not straight. So that's pretty straight. So once you get the cup straight in there, everything's level, it's straight. Now you're ready to set your project up. So when you set your project up in Laserbox, Creative Space, Lightburn, whichever, always with the rotary tool, the RA2, I recommend always doing a test burn. Do not just put your project in there and assume that it's going to come out the way that you think it's on the screen there. So what I use is I've got foil tape. This is adhesive foil tape, like for HVAC ducting, and I put masking tape on top. And once I have my cup in place, I just tape this over the top like that. It does not have to be perfectly tight. It can be a little bit loose as long as it doesn't fall off. And this will allow me to do a test engrave of the project before actually burning the cup. So with this foil tape, it's aluminum. This laser will not go through that tape. So at 100% power, it will not burn through that tape. So I can burn it. You can see I've used this a couple of times. It's got other stuff on here to check orientation. Always with the RA2, test burn. Put something, a protective layer over it, and run the program. You can raise the speed if you want to do a quick test instead of the same speed that you would engrave with. You don't have to have 100% power. You can do less and just do a higher speed and just quickly look and check it. But always test it. So we're gonna put the test panel on there. And another thing, when I have one with a mug handle, depending on the size of the mug handle, I take a block of wood. So if the mug handle was on the other side, I would take this block of wood from here all the way over the block of wood to the bottom. That way it counterweights the handle weight of the cup, because the handle will cause it to fall out of place. It will cause your cup to turn because of gravity pulling down on the handle. So if you counterweight it, if you're doing a design that wraps all the way around, you're probably going to remove the handle if it's a Stanley or something like that. If it's a Yeti cup and you're going all the way around, you might want to counterweight it on the inside of the cup, on the opposite side of the handle. So it might require a little bit more weight than it would have normally taken. So you can put weights in there, some tape weights or something like that. Tape it to the inside of the cup on the opposite side of the handle, and it will help to offset that weight so it doesn't droop on you. Once the project is started, the stepper motors will not let that handle pull it down. So you should be okay once it's started, but when you're framing it and checking it, that handle definitely plays a role. So when you have a handle on there, you get it counterweighted. You've got your handle here, your weight over here. Your first framing, take your laser and put it over there in the corner. Don't leave it here. Set it to where it's going to move in free space somewhere else. If you leave it here, what I've had done before is I've gotten everything set up, and during my framing, my handle or the wood will contact pieces of the laser and cause everything to just blow out of place, and then I have to reset everything up. So, little word of advice, just push this over here, maybe just right above it even, and do your framing in free space. That way you don't lose center. You can just put it kind of over here and run your framing and watch the way the cup moves and see if you think that handle is going to contact the laser module or not. Because I've had it happen, and it's not fun because then you have to reset it up and then try and do it again. So this one doesn't have a handle. We're not going to worry about that too much. I'm going to put that there so that we can run a test. I'm going to show you what happens in Laserbox. when you just put an image in and don't do any altering to it. And then I'll show you how to alter it to make it look correct in Laserbox, or engrave correctly out of Laserbox, where creative space has already been corrected. There's a tool inside. You can click that it's the rotary, the chuck tool, and you can put in the diameter of the cup or the circumference, and it does the correction for you so that you don't have to do this manually inside the program. But if you're still using Laserbox, or if you're using Lightburn and having problems, this could help you. So let's dive into Laserbox real quick. Okay, here we are in Laserbox, and I'm just going to go ahead and bring in make a simple design here. What better than a circle, right? Because we get to see how it gets distorted on the cup. Just making it round at 45 by 45. And I want to put some words in there. So we've got this set up. Simple design. I went ahead and just put Mayhem Made. That's the channel. So we're going to do a simple engrave with a circle. And with text, we can tell what direction it's headed. I'm going to set it up like a normal tumbler here. So my tumbler is facing with the top side to the right. So if I rotate this 90, that is the way that it's oriented on the laser, as you would kind of expect for it to come out. I'm going to set this up. The power doesn't matter. We'll go for higher speed. We're going to go ahead and put that onto that and see how it looks. Okay, make sure you have your laser glasses on. I'm going to set this right at the top where I would normally set it up. Turn cylinder working on. Go ahead and press start and see what this thing does. Okay, so we are done there with that. So look at the orientation on that. You see the wording? You see it's completely backwards. We're backwards on that. It's the right side up, but it's mirrored. It's backwards. You see that the circle is very stretched. I'm going to go ahead and measure that circle real quick. So my circle was 45 by 45. It is 45 tall, which this direction didn't change. It's this direction that changed with the rotary. So I set it for 45, and it is 57 millimeters wide. So it grew by 12 millimeters. Supposed to be 45, went up to 57. So in my laser box, I'm going to take this image and I'm going to mirror it. So that should correct the orientation of the letters. And then the size of all this, the width was messed up. So the height is our width on this, on the cup itself. So it went up 12 millimeters. So that's not a direct correlation. You cannot just drop 12 millimeters off and say that it's going to work. So taking that down, I want to try and take off 8, see what happens. So I'm going to go 37. So you can see how the design starts to get squished here. So it's getting squeezed. So you've got to recognize here that the design is getting squeezed, but it's getting stretched out by the steps of the rotary tool because of this gear reduction. See this pulley? How big it is compared to the drive pulley? That's where the change happens. So you have this gear drive that's getting relayed to the cup size, and it's getting skewed in there. So this gear reduction and then the cup size, they all multiply together. So if you have a bigger cup, it's not going to be the same ratio difference that you have here with the 12 millimeter growth. It's going to be different per cup size. So the diameter and the circumference they're related, so you can take one or the other to get this relation. And once you figure out a certain ratio for the cup size and you use the cup size repeatedly, it should be the same ratio change for the width adjustment. But when you change the width adjustment, you got to know that your lines per inch, if you're adjusting lines, you need to go up just as much as you squeeze this, because it's getting stretched on the rotary, and it's going to be, if you put 120 lines, you're actually going to get about 90 lines. So you've got to know that that stretch is happening and it's stretching out your line count. So you need to increase line count to compensate. So we've got this. Let's go ahead and send this. Setting it up at the top. Cylinder working on. Go ahead and press start. Okay, that just finished up. Okay, you can see there, the orientation is correct. You can read it, it says Mahan made on there. Let's go ahead and measure the circle. So that circle was 45 by 45 originally. And right now it is 45 by 46. So you see it was 12 millimeters off originally, and I took off 8 in the program, and it made that correction of 12. So that was just a lucky guess. I didn't have any reason of why I picked 8. I figured it would be a good number to start with. So that got me where I need to be with the design. It's round. It's got Mahan made on there in the correct orientation. It's going to come out right if I go ahead and pull this off. If I take the tape off, I can go ahead and engrave. It's all ready. So then you just take this off, set it to the side. I've been reusing that same one for a long time. And then you orient your cup where you want your design, and you go ahead and burn it on there. Make sure that if you change the settings to go fast to check your design, that you go back in the program and change your settings where it's correct for your material. So fix the settings, do your 100% power with this machine. If I'm doing a high line count, I'll do like 100% power and 90 millimeters per second with 160 lines, and it will come out nicely with these cups. It'll burn off, and the soot cleans up easy. It comes out good with that speed and power. For now, I'm going to show you another way to set this up. So in the program, if you go ahead and press start in Laserbox, and you set this up in the center, cylinder working on, turn your speed way down on framing. So I turned it to 10 millimeters per second, and then get yourself a pencil, just a regular old pencil. And when you press, I've got a wireless mouse, so I bring it over here with me, and I can press frame, and it's going to frame it nice and slow, and I can make a mark on this line right here. See where the crosshairs are? And then I can make a mark where the crosshairs go. It might take a couple of tries to get this. So we'll frame it again. So I made a mark right before it moved. Sometimes the designs are small and it goes fast. So I made a mark with the framing, And you can measure that framing as long as your space is set up correct. See, that's right at 46 millimeters. So instead of doing all the test burns, this is going to wash off with water. It's not going to hurt the cup. I've done it several times with a pencil. It washes right off. It does not stay on the cup. Nothing to worry about there. When you're doing this way with the framing, as long as your design does not have any white space around it, make sure that everything is cropped to your design so that that's the way you can best size your project anyways. Is get all the white space out. Project needs to be the same size as your space. So it's cropped down to the design, and then you size your project so that you can know what it's going to be on the cup or wood or whatever you're putting it on. But you know how, in the framing, you know how big it's going to be. If you're cropped down in the design all the way to the edges and you size it for that, and you frame it, it should equal that. So you can skip the test prints or test designs if you want, as long as you know the orientation is going to be mirrored. And then check your width. So run the frame, make a mark, and then measure it. And as long as it comes out to what you expect, you should be good to go. So on that, this one measured 46. That's exactly what I just lasered on the cup on the test panel was 46. So either way, you can check the width, but it would have come out 57 before because it was wrong. And then you would have to alter it until you got your 45 or 46 this way with the pencil. But with the pencil, you can't see if the design's going to come out in the right orientation. So what I do recently, I test it with the orientation with the test panel, and then I use the pencil method for framing to check the width. Because the width I want, usually with tumblers, I go 10% wide anyways. So if I wanted it 45, I would go 48 or 49 so that it's 10% bigger than the design, because the circle is not going to look like a circle on a curved surface. It's going to look like an oval. So if you stretch it a little, and it'll look like a circle when you're looking at it, because it's an illusion with the curved surface. So if we wanted that 48, we'd have to raise it 1 or 2 millimeters on there, and it would compensate for that to give it that 10%. So that's how you would do it in Laserbox. And from there, you would just go ahead and fix your settings, laser it on, make sure that it's where you want it on the crosshairs, or if you're using the dot. Now we'll jump into creative space. Okay, here we are in creative space. I'm going to go ahead and insert a circle. I will size this 45 by 45, and then lock the ratio. I'm going to make text just like I did before. I'm going to go ahead and set this up. I'm not going to worry about, I'm not going to do a test. Yeah, I'll do a test panel in here. So we'll set this up to fit. So I'll go ahead and do an engrave. I'm going to set this kind of high. We'll do 100 so it goes fast. I'll set this at 50% so we can see it. We'll go 100 lines. Set up this circle as an engrave. Well, yeah, we have to do score on that one. So it just makes a circle. So we'll do 50%, around 50. It doesn't have to be perfect. It's just a test. And then we'll go 100. I guess we'll do 80. Okay, we'll make this fit inside. Okay, so there's that. You hold control and you use your scroll dial. You can zoom in instead of using your zoom functions. So just hold control and you can just scroll in or out. So we've got both of those set up. So for engrave, and I want to rotate it. So let's box highlight everything so it all moves together. We're going to move it to the side so that up is up on our cup. Okay, so we've got that set up. It's 45 by 45. Click outside of the design. We're going to click here with the cylindrical, and then we can click the chuck, and then it opens up these options here. So putting in a perimeter or a diameter will auto input the other because they're proportional, and you will be able to get a correct ratio of steps on the motor. So this basically is in the middle here. So you can see that a diameter is going to be hard to achieve. So I'm going to guess it and go 80. And then I'm going to do a circumference measurement. So using a flexible measuring tape right where the design is going to be. So we've got the crosshairs right about here on the design, or on the cup. We're right at 270 on there. So this is the same cup, it's just new and not on there, so that I can, if you're going to do this, make sure you measure your cup before you put it on, because it's going to be difficult to measure when you have it set up. Diameter, we can put 80, and see that comes out to 251. So we measure the circumference, which is more accurate than the 80 because I guessed on the 80. So we're going to do 270 for the perimeter, and see that comes out to 85. So just looking at it and eyeballing it, you could make a mistake and put the wrong diameter in there. So measure twice, make sure it's right. If it looks feasible when you put it in, it's probably good, but if it looks like it's not right, measure again, make sure you get it right, because this is going to compensate for that stretch. So I put those in. I've got my design is facing how it looks on the cup and how it should come out. I'm going to go ahead and process. I'm not going to frame this. I'm just going to go ahead and send it to the laser. I'm going to put this at the top like I normally do. I set it for the top. Send it to the laser. All right, so we are complete there. You see the orientation is correct. Let's go ahead and take a measurement. So this was 45. I don't know if you can see that in there, but it is exactly 45. So I'm glad that in Creative Space I just started using it. I'm really glad I did, because I do a lot of stuff on the RA2. Okay, so you can see that this pattern, I take this off, it does not go through at all. There's no risk to the cup. I still do this every single time I use the RA2. When I'm doing a tumbler like this, I don't really worry about doing a test, because I've tried it so many times. It never messes up on me because I use the rotary that has the foam rollers, and it has never failed me. So doing a normal cup like this that can go on the foam rollers, glass, tumbler, whatever, you don't have to do as many checks. But with the RA2, I've had it to where I go in the program and mirror something and mirror it back, and it's completely messed up when I go to laser it. So always do a test pattern. So make yourself a panel, get yourself some aluminum tape or something to block it, so that you can do a test on the orientation. A lot of the designs that I do are more complex than this, so they take a whole lot longer to do the full design. So I use this at the start of it, and then I will stop the program After I know that the orientation, I can see something identifiable that shows me the orientation of the design. And if it looks correct, I'll just stop it. Or I may need to see some more to see what needs to happen to fix it. So I check it on this every single time. And once I see the orientation, I stop the design. And then I take this off. And then I do the pencil method to check the width. So I don't want to sit there and engrave the entire design because some of them are kind of large and detailed and take sometimes 30 minutes to do one of these designs. So I don't want to do a 30-minute test panel. I just do enough to where it shows me what I need to see. And then I take this off, use a pencil, check the width, make sure that I adjust it for my 10% growth over the curve, and adjust it from that with the framing again. It's pretty quick to set up that way. That way, I don't know about you, but I don't like buying stuff and just wasting money. So if a customer brings me a Stanley Cup or a Yeti Cup or whatever, even if I have to buy the Yeti Cup or Stanley Cup, or these cups are expensive. So if you laser on it, it's permanent. It's not going to just go away. You have to either sandblast it or sand it down and re-powder coat or just scrap it. You know, I've got some scrap cups that I have screwed up on, and it's not a great feeling. Do your test burns. Make sure it's correct before you start, and you're going to have good results every time. So the other thing that you have to work through is the lines per centimeter, and find your settings that works for you the best on the colors. The colors of the cups, they matter a lot. So the black cups are not going to burn the same as the white cups. Purple cups, the pink cups, those things, they never burn good for me. So you've got to do your test burns and make sure that everything is going to come out as planned or close to it so that you can recover it. So that's how I set up the rotary, the things that I go through. I hope that this helps you guys with the rotary and setting it up and understanding how things relay from Laserbox or Creative Space to the laser. If you're still in Laserbox, it might be worth going to Creative Space just to simplify this whole process of the RA2. So I hope you enjoyed the video. I appreciate you watching. Give it a like if you liked it. Subscribe if you're not subscribed. And we'll see you in the next one.